All right, we're ready to go. All right, so next 3 days, we're gonna do chapter 9, correlation and regression. The first section is mostly just about our correlation, and the regression is the line that goes along with that correlation that we'll talk about in 9.2. All right, so correlation is a relationship between two variables, x and y. So we have these ordered pairs. X represents your independent variable, y represents your dependent variable. Our book also uses a little bit different terms that you might see in replacement of independent and dependent, explanatory and response variables. You might see those words instead, but just remember that the x is your input. It's going to be along your horizontal axis. The y is your output, your dependent variable. It depends on whatever your x is, and that's going to be on your vertical axis. When we talk about correlation, we are going to focus on linear correlation, so a line that could represent the general trend in the data. There are other types of correlation, other types of regression, quadratic regression, cubic regression, exponential regression. Those are things that you learn in other classes. We are going to focus just on the linear one for now. All right, so the first thing we're going to label on this, and this is on your worksheet, is just what type of correlation I have. And so for this, we're looking for, first of all, is it linear or not? Could a line represent this data? And if it is linear, is there a positive correlation or a negative correlation? And that you can think of as like the slope of the line. Positive correlation, the general trend in the data is going up from left to right. The negative correlation, the general trend in the data is going down from left to right, or as one increases, the other decreases. So in that first one on the top left, could a line represent the general trend in that data? Yes. Okay, so it is a linear correlation, positive or negative? Yes, so it is a negative linear correlation. We're going to label it. What about the one on the top right? What type of correlation do we have? Positive, linear. Okay. Bottom left, could a line represent the general trend in that data? Is there a trend in the data? Not really, it's all over the place. So we say there is no correlation between those two variables, whatever x and y stand for. And then the last one, linear or not linear? Could a line represent that data? Not unless it's a curve, right? So this is what we call non-linear correlation. That's an example of a quadratic, like a parabola would better represent that data. So we're just going to call it non-linear. All right, any questions there? Great. All right, we'll make scatter plots later. We'll worry about that. Let's just review. Okay, correlation coefficient. This formula is at the bottom of your definition sheet. I just put all the formulas for chapter 9 all on that same page with the definitions for you because we don't have very many there. Correlation coefficient measures the strength and the direction of your linear relationship between two variables. We're going to use R, and that's going to represent the sample correlation coefficient. So if you have a set of sample data and you calculate the correlation between that sample set of x and y values, whatever they are, we end up with R. The population correlation coefficient looks like a lowercase p, but it is not. Notice the kind of cursive shape of it there. It's actually the Greek letter rho is how we would pronounce that. So rho represents the population correlation coefficient. So that's if you had all the data points for a particular set, the correlation coefficient would then be rho. But for the most part, what we're going to be using is R, and R is what our calculators will calculate and what our formulas are going to be for and all of those things. We're going to calculate this in a second by hand, and yes, our calculators do it, but what fun is that? So we're going to do it by hand. This is going to look like big columns of information, kind of like what we did with standard deviations a while ago. We're going to fill out all of our columns, and then the sums of all of our columns are what we're going to be plugging into this formula. So we're going to have x's, we're going to have y's, we're going to have x times y's, we're going to have x squareds, we're going to have y squareds. Plug it all in, and then we get this single value R. R values will range from -1 to 1. So the biggest R value you can have is a positive one. The smallest R value you can have is a -1. +1 and -1 represent perfect linear correlation. If it's a +1, it's a perfect positive correlation. If it's a -1, it's a perfect negative correlation, which means if you look at those pictures, the scatter plot, the data would make a perfect line. There's nobody out of place. The line that I would create would hit every single data point. If you have no correlation, like that picture that we saw a minute ago, your R value is going to be close to 0. So we have kind of like this number line we're going to be thinking about. -1's the lowest, perfect negative. +1's the highest, perfect positive. And then in the middle we have 0, which means there's no positive or negative correlation. There's no correlation in general. The difference between strong and weak can be debated depending on what book you read. What I like to say is 0.7 is going to be our magic number. If you have 0.7 or higher, we consider it a strong correlation. So 0.7, 0.8, 0.9, 1, those are strong correlations, or negatives. -0.7, -0.8, -0.9, those are strong negative correlations. Anything between -0.7 and +0.7 we consider to be a weak correlation. Okay, so think of 0.7 kind of like that magic number that's going to make the difference between strong and weak correlation. All right, on your paper, the next activity I want you guys to do, this is a matching activity. So I've got 6 scatter plots made for you here. On the right, I have 6 R values and I have 6 descriptions. I want you to each graph match its R value, its correlation coefficient, and match the description of the correlation. All right, so I'll give you a few minutes and then we'll put it up on the board and check. All right, these look good. What questions do you have? Using correlation coefficient to describe the trend in the data. Weak, perfect, positive, strong, negative, all the things. Okay, great. All right, so let's go ahead and calculate these R's. And we're going to calculate them by hand first. You can expect on your quiz on Friday that you will be calculating them by hand. And then we'll just be checking with the calculator if we need to. All right, so you really don't need to write these steps down. Pretty much it says just you're going to fill out all the following columns, which I've got set up for you on your paper already there. You're going to do your x's, your y's, xy's, x squareds, y squareds, and every single column you're going to sum up. Then those summations you're going to plug into the following formula. And again, the formula is something you would be given on, a test or a quiz or whatever. N is the number of data points that you have. So if you have 10 data points, N is 10. We've used that before. Be careful of these radicals in the denominator. There's a difference between the sum of x squared and the quantity sum of x squared. So sum of x squared would be all of our x squared columns summed up. This one here with the parentheses is the sum of our x column quantity squared. So the parentheses makes a big difference on that. So you're going to be careful when you plug that in at the bottom. And then you plug it in, type it in your calculator, simplify. You get some answer between -1 and +1, and then we can interpret that. All right, so we're going to do this one together. You need a calculator if you haven't grabbed yours yet. There's going to be a lot of multiplying, adding, squaring, all the things. All right, so we've got in this set number of years out of school, and then annual contribution to something like an IRA or back to the school for a donation or whatever this happens to represent. All right, so we're going to fill out each column, and then we're going to sum up all the columns. First thing I need to do is multiply all my x's and y's together. So 1 times 12.5, 12.5. 10 times 8.7, 87. 5 times 14.6, 73. 15 times 5.2 gives me 78. 3 times 9.9, 29.7. 24 times 3.1, 74.4. And 30 times 2.7, 81. Okay. Then I need to do all of my x's squared and all of my y's squared. Squaring my x's should be fast. 1, 100, 25, 225, 9, 576, and 900 are all of my x's squared. All of my y's squared, probably want a calculator for this one. 12.5 squared, 156.25. 8.7, 75.69. 4.6 squared. Oops, wrong button. There we go. 213.16. 5.2, 27.04, 9.9, 98.01, 3.1, 9.61, and then 2.7 squared, 7.29. Okay, now you're going to sum them all up. Sum of x, sum of y, sum of xy, sum of x squared, sum of y squared. All right, and double check me. Make sure I've got all these columns right here. First one, you should get 88. $56.7. $435.6. 1836. 587.05. Excuse me. What's my n in this problem? So we had 7 points to start. So n is 7. That should be everything you need for the formula then. All right, so I'm going to write this formula again at the bottom here, and then we're going to fill it in. So r equals n times the sum of xy minus the sum of x, sum of y. And then the denominator, we've got our two square roots. They look really similar. The first one's our x's, the second one's our y. So n sum of x squared minus quantity sum of x squared. N times the sum of y squared minus quantity sum of y squared. I can move this down a little bit. Oops. Here we go. All right, so filling it in. Again, n was 7. So that's going to look like 7 times the sum of xy, which was 435.6, minus the sum of my x's, 88, times the sum of my y's, 56.7. In my square root, n again, 7. So sum of x squared, no parentheses, is that 1836 minus the sum of x, that's our 88, squared. That's one you have to be careful about which one's which. All right, and then same thing with the y's. N times the sum of y squareds, which was 587.05, minus the sum of my y's, 56.7 squared. Okay, And then you can type the numerator in, type the denominator in. That's probably what you would want to do with the basic red calculator. Simplify the numerator and denominator first, and then divide last. With the graphing calculator, you could type it in all at once. My numerator gives me negative 1,940.4. Denominator. Make sure in the denominator, after you do the first square root, if you're in the graphing calculator, you arrow to the right to get out of the square root or hit multiplied by before you do the next one. In the red calculator, you might want to do both square roots first and then multiply them together. Just try not to round too much in the middle if you can avoid it. You get 2,137.499. Give it 3 decimal places down there. And then you divide. And remember, you should get an answer between -1 and +1. I get negative point, I'm going to give it 4 decimal places, 9078 is my sample correlation coefficient. So if you had to interpret that, what would you say? Strong or weak? Positive or negative? And these always, when we calculate this formula, will be for a linear correlation. So that tells us for this set of data, this x and y, as one of the variables increases, it makes the other variable or dependent variable decrease. Okay. I'm going to show you how to check this in the calculator now too, if you want to do that. Go to your stat menu. Oop, let me get mine loaded up. And I want you to put your data in L1 and L2. That one. Maybe. Okay, so stat edit. Put it all in L1 and L2. Clear out your list if you have anything else in there. All right. Okay. Once you have your data in there, this is probably going to look familiar from your previous math classes. So you're going to hit stat, go over to calc, and then number 4, linear regression. So this is going to give us 2 things. It's going to give us the R value, which we need for right now. And then when we get to section 9.2, it's also going to give us the line of best fit, the regression line that we, again, will be calculating by hand because that's more fun, but we can check it. So if you hit number 4, so stat, calc, number 4, you guys should see L1 and L2 there. Does anybody not have L1 and L2? We're good? Okay, so just go down to calculate. And what we're looking for right now is that R value, and you can see the R value is negative 0.9078. It's the exact same number that we just did. Okay. If you want to see the data in your calculator, it might help if you're doing your homework. Go to y equals. Yeah?
I didn't get that.
I
only got A, B.
Oh, your R didn't show up. Okay, so we just need to change something real quick. Hit mode. And then if you go down to where it says stat diagnostics, towards the bottom, turn that on. Okay, so now do it again. Stat, calc, 4, enter, 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 enter. And now you should have an R. Yeah? Are we good? Okay. All right, so go to y equals real quick. Turn your plot on. Clear out anything else that's in there. And then, do you remember which zoom we use if we're zooming in on data? Zoom 9. Zoom stat. If you hit zoom 9, you'll see a nice picture of the scatter plot then. So you might have to do that in your homework. You can, of course, make a scatter plot by hand, but you can get it with the calculator also, as long as you make sure that that plot is on Zoom 9 every time, because that's going to zoom in on the particular window that you need for that set of data. If you want to see what the window is, like what the X and Y axis are labeled, you can hit window next to Y equals, and you can see what the X min and X max are. That's your X axis. The Y min, Y max, that's your Y axis. So then you could draw it by hand if you needed to and make sure everything's labeled then as well. All right. When we get to the next section, 9.2, we'll put the regression line on top of that also, and you can see it all in one picture. All right, last problem for the day is yours to try. It's on the bottom of your paper. I want you to take this set of data, fill out all your columns, find the sum of every column, calculate the R using the formula by hand, which is what you're going to have to do on Friday, and then you can check it with the calculator when you're done. All right. But you probably can check your own work just by looking at that calculator. All right, so you've got the sum of all your columns. That's probably the first place you want to check if something's wrong. And then you can double check the numbers in each column if one doesn't work. And then this is what the formula looks like filled out. I simplified the numerator and denominator, divided. I got negative 0.1639. I'm going to give it 4 decimal places. Pretty close to 0, so we say it's a weak negative linear correlation. It's not fun. It's like therapeutic, right? Just fill out the formula, fill out the columns, fill out the formula, plug it in. Easy. Okay? No crazy word problems, just find the number. That's it. All right, we will finish up 9.1 tomorrow. And then 9.1 and 9.2 Math Excels are both due on Sunday night. And that'll be the only Math Excel for the next couple weeks, or those two. So try a little bit each night. Try not to use the calculator too much on your Math Excel. Maybe at least try one of them on your own without the calculator before you start calculating in there. I know it does save you a ton of time, but you want to make sure you can get it right. All right, and I'll do the cell phone lotto, and that's it for today.